Hello and welcome again. In the previous video, part 1 of the static routing configuration, we managed to cover the static routing, the interface configuration of this router 1 from here and here, but we haven't done both sides, the serial interface and the fast Ethernet of router 2. We've done here, but not this side. So we will continue from there, configure this interface so that interface comes up. So what we will do, we'll go back and check how far we have completed. So if we say show IP interface brief, if we do that, brief with I first, then it says the fast Ethernet or the local LAN interface is up, but the WAN is still missing. It hasn't been configured yet. So this is the LAN for this router, and that's the WAN for the router. So let's configure the WAN router, which is WAN interface, which is the serial. So if we go to the configure terminal and then go to the interface serial 0/0/0, then give the IP, and that IP is from the subnet we have done for router 1 10.2.2. that one took .1, and this router 2 is going to take .2. So we're going to do 10.2.2.2, and the subnet mask is 255.255.0. The subnet mask is 255.255.0, and then we say no shutdown. And when we do that, the interface came up. So if you see, it's a green. So these two routers now can reach each other. But the device on this this computer here, on this subnet 10.1.1.0, and it has the IP 10, cannot go all the way to that device. And to do that, we need static routing. But let's test first. Here we've got 101 from this router, from that server. That's the one we want to test all the way from here, going through that router. Can we reach this server? If we can, the routing is in place. If we cannot, then we have to check the routing. We haven't done any routing yet, but just to confirm before everything, we need to set up that kind of test. Let's save what we have configured on R2 and use the command copy running config to startup config. Whatever we have done in router 2 now is saved. If we now go back to the router here and check it is IP address, so the IP address of this router can be checked from this command prompt. So if we say IP config, it says my IP is 10.1.1.10, so 10.1.1. The subnet is .0, but we give 10 here and 11 here. So, and the default gateway is the router interface, which is 10.1.1.1. This one is for that router. So we know that IP, if it pings it is default gateway, which is a router, it can reach that. So if we say ping 10.1.1.1, that's the router, we can reach up to here. If we ping the other side of the router, which is 10.2.2.1, we are also able to do that. So if we say ping 10.2.2.1, we can do that as well. So we're sending 4 packets and then receiving the 4 packets. Nothing is lost, so 100% success. But the issue is we can also probably ping that network 10.2.2.2 for that router, but not the other side. And let me just check. I'm not sure about that one. So let's check. And if you don't get a response, yes, we cannot. So here, for this router, those interfaces we can ping, it's the same device, but when you go off to the other router here, then we cannot do that. So that means forget about going all the way to the server on this network. We can't even ping this interface. So we have to come up with a solution. Solution is to tell this router, if you receive source IP from this subnet, which is your LAN, go into that destination, forward it to this router, and this router's interface is 10.2.2.2. Or you can say, if anything coming from this subnet is going there, exit from the serial interface. So 2 ways. You can either name the interface or give the IP of the next hop. So let's go to the router and say, go to the enable mode, go to the config terminal, and then say IP route. This is the destination you're going to. We're saying, hey router, this router here, if you go into that subnet, which is, the command says IP route, that subnet is 255.255.255.0, then we need to tell you're here forward to that router, which is 10.2.2.2. So we give the next hop. If you put a question mark there, then it tells you how many options you have. So put question mark, and then it tells you you have an IP. You can put a dialer, Ethernet, all these things. But we need to put the second, the next hop's IP, which is 10.2.2. Now we have a root, and if we say end, and if we save it, we can use copyright, write to memory. And then if you say show IP root, we check in the root that's in place. This is the connected network for this router, which is 10.1, and the other connected network is 10.2.2, but that 10.3 is not connected. It's going through S, which is static over here, and it's going via a hop, which is via the next hop router, 10.2.2.2. So that root is in place. But if you check the other router, there's no root. Show IP root. It doesn't know this network. 10.1.1 is not known. It's not in the list. So we need to add that to the root. And we say IP root 10.1.1.0 255.255.255.0. And sorry, we didn't complete the next hop. The next hop is you're here, and you have to forward it to this router, which is 10.2.2.1. Now that's in place and it's there. So if we check the root, we can see now that IP is available. So if you're coming from here or going from there, the roots are in place. So we can say the same ping we couldn't do, now it should work. So you can see previously it was timing out, but now we have sent 4 and we can receive the 4 replies. If you see now the IP we check in here is this server, and this server is actually running a web server. And if I check it is IP in the desktop, it is 100, and that 100 we can ping, and this one says 101, and they're both running web servers. So if you click on this one and leave it there, actually ping from here, go to this router, this computer, and ping the IP 10.3.3.100. That's the web server on the right hand side. The first one is not in the app cache, so it will miss that ping. Second one or the third one will come up. So we have the second one coming up. We sent 4, and we receive 3. We lost 1. So if we repeat again, now it's in the cache, so we're able to see everything. And this is actually a web server, and 101 or 100. So what we're going to do is access the web server as if you are accessing your Gmail account. So go to the web server, and if we add the web server, it takes a little bit of a time for this application, don't know why. So we wait. Yeah, the IP is 10.3.3.100, and then if you see, it says test page, and that's the page here, test page. If we check the other one, which is 101, and put 1 there, then it comes up. This is my page portal. This is a HTML file. You can put your website there. So that means if you're a user over here, you can go all the way there to access a website in another city, and that is allowed by static routing. So this completes our basic labs of understanding the basic static routing. In another video I will record, instead of using the IPs, we need the website name, mypage.local, and that is allowed by DNS or domain name service. So if we have a DNS service over here, and that is resolving the names to IP, then we can reach by just typing the name, and we can route. So we're using now 2 services, the routing service and the name resolution service. So we'll stop this one here, and in another video I will record those services. Thank you for your time.